welcome to the BS and Beer Show, where BS stands for Building Science. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. Shout out to my friend Jake at Salt Lake, who made this snazzy shirt for us. Um, the Brew Crew and our guests volunteer our time each month to bring you what we hope is fun and an informative discussion. Big thank you to IMW Group and Motif for their help with media communications. And to keep the lights on, we like to spread the good word, so we heartily thank our sponsors. But tonight, we are going to share a little something with you. It's the International Builder Show. So if you weren't at the International Builder Show and you want to meet some of our sponsors in person, we highly recommend that you attend one of the building science symposiums. If you missed it at the show, Travis rolled out the dates and location for this year's symposiums. So this year, the Building Science Symposium is going to hit 5 cities. Houston, April 7th and 8th, Salt Lake City, May 5th and 6th, Milwaukee, Wisconsin, September 1st and 2nd, Richmond, Virginia, October 6th and 7th, and Atlanta, Georgia, November 10th and 11th. These are all live right now if you want to get tickets to the symposiums. You'll hear from Steve Basic, Joe Stiebrick, John Straub, Jake Bruton, Ross Trethewey, Ben Bogey, lots of other speakers, and I want to specifically highlight Christine Williamson is going to be at some of the events, and it is Women in Construction Week this week, so shout out to Christine. I plan to go to this symposium because it's an honor to hear Christine speak every time. So, Rockstar Crew, happy Women in Construction Week. So, the sessions focus on real-world challenges for builders, designers, and trade faces, covering everything from building enclosures and control layers to durability, energy performance, practical high-performance strategies you can apply on your next project. So if you'd like to join the conversation, you can take a picture of the QR code here. They are all live right now. And Mike will probably drop a link in the chat if you're not a QR code kind of person or you're watching the show on your phone and you can't click on the QR code. So big shout out to the symposiums and Travis and what he's doing with those. So don't miss out. On with the show. Go ahead and introduce yourself in the chat so that your friends and colleagues alike know that you are here. Only the 4 of us can see who's here. So put your name in the chat and, of course, tell us what your beverage of choice tonight. I'm rocking some BS and beer gear from Jake here, or if you would like a hat, a glass, or a coaster, you can go ahead and check out our friend at BS and Beer Boston who's making some fun merch. So if you visit the website, thebsandbeershow.com, for more information. You can find local groups in your area, links to past shows on YouTube, join our mailing list, and information on how to start your own group. So without further ado, let's raise a glass and Mike can tell you the rest of our announcements.
Thanks, Emily. Mike Maines. I am drinking a lovely Spindrift grapefruit tonight. I did drop the link to the Building Science Symposium series in the chat, so go ahead and click on that. Also coming up, this is conference season, so BE26, the Northeast Sustainable Energy Association's annual conference in Boston, will be March 23rd to 24th. And will feature a presentation by our friends Jacob Rehusen and Ben Bogey titled Less Carbon, Same Building, How Builders and Designers Can Cut Embodied Carbon Today. If you have never seen them speak other than here, they are fabulous presenters, and I might have just been convinced to go myself. We'll put a link to that in the chat. The Journal of Light Construction's JLC Live is March 26th through 28th in Providence, Rhode Island. Ben will also be presenting there, along with other trusted friends of our show. For those who didn't make the NESE conference, can get a second shot at Jacob and Ben's talk on less carbon, same building session. We'll put a link to that in the chat. And those happen to be back to back, just in case you want to hit both of them and get more Jacob and Ben. Following those, May 6th and 7th is Better Buildings by Design in Burlington, Vermont. That's always a good show, kind of a mini NESE conference. And if anybody else has other conferences or things of interest, go ahead and put those in the chat box. If you want us to talk about anything for next month, just email us, info@bsandbeer.com. And our next show will be April 2nd with special guest Glenn Mathewson. I think we're talking about decks. And I will turn it over to Ben to go from here.
Thanks, Mike. I'm Ben Bogey, Building Performance Cooperative in Connecticut, and this evening I'm drinking a Treehouse Maple Praline Coffee Milk Stout that my neighbor gave me for letting him borrow my snowblower recently. So nothing better than a free beer and one that was well earned. So this evening, I have the pleasure of introducing my friend Danko Davidovic, with more than 20 years of experience in research, forensic consulting, manufacturing, and building science education. Danko focuses on one thing: understanding how building assemblies actually perform when it comes to heat, air, and moisture transport. His work spans laboratory testing, field investigations, and advanced hygrothermal and computational modeling. Danko works at Huber, where he leads the R&D efforts centered on building envelope performance characterization, evaluating water resistance, air tightness, durability, and long-term moisture behavior of wall and roof assemblies. He's designed and constructed instrumented mobile test huts and a walk-in weatherization chamber to study full-scale assemblies under controlled and real-world conditions. His work combines experimental testing with numerical analysis to better understand how materials and systems behave over time. Danko is also deeply involved in industry standards. He is a licensed professional engineer and is involved with both ASTM and ASHRAE, including leadership roles focused on moisture management and building envelope performance. And Danko, I'm proud to have gotten to know you over the years and call you a friend. You are also a phenomenal drinking partner and a damn good musician. So,
certain things you have to stay a secret, man.
sorry, I let that one. Just one more, Danko. Just one more.
Thank you. Yeah, that was like long introduction, man. That's a lot of things to memorize. Even I can memorize all these things. So anyway, I'll just say I wish I had the neighbors like you do. Have to give you that beer. I wish I had a little more snow in Atlanta to have that
Don't wish
opportunity.
for those things, though. You don't want
I'm just
that.
joking. I'm just joking. So yeah. So this is a choice of drink for me tonight. It's like light pilsner because like on Tuesdays and Thursdays I usually go do a little run after work from my neighborhood. So I'll try to stay light tonight then.
Well, I believe we have a presentation. I'm not sure if you're pulling that up or if Emily is
Yeah,
to
I mean
kind of
I'm
kick us into the
fine.
conversation here.
Yeah, if
Yeah,
you
I
want to
mean
share, that would be good, but I have it available if you need me to.
yeah, I know it's typical laid back conversation. If you have anything else that's kind of more urgent to discuss, I'm fine either way. We can talk about all these other things first and do this at the very end, or vice versa. It's
Okay.
Well, I'd be happy to. You know what I'm curious to know is what got you into this field of work and research, because this is kind of a bit of a niche area. What drew you into this?
Well, that's really good question. So, back in my overseas days, I had a dream to become like HVAC engineer. So that was my college degree from Belgrade in Serbia back in the day. And then the economy and the times were not that great at the time when I was finishing my college. So the opportunity came to come to the United States in 2001. Although I started my master's program in HVAC overseas and focus on geothermal, sorry, like the hydronic systems. But the opportunity, Penn State came on board to study ventilation drying in the wall assemblies. So, okay. I never assumed I would ever think in my life about things like that. So I came to Penn State, did my master's on that topic, and then I realized how crazy it is to predict what the wind is doing for ventilation around the buildings. I said, I want to study that a little more detail, and then did my PhD studying the airflow around the buildings, doing some wind tunnel experiments, some CFD modeling to prove my wind tunnel measurements, et cetera, et cetera. So that's how I slowly shifted from HVAC into the building science and building envelopes. But I would say at the end of the day, when I draw the line after all these years, I think it's a good mix and a good package overall because you have the understanding of both things, like a mechanical system and envelopes, exterior environments. So I would say it was a good choice back in the day. So I do not regret it at all.
I want to know what's the most unexpected experiment that you've done.
Whew, most unexpected. Well, the most unexpected one when you create some experiment and you kind of shooting for certain results, you think that's going to be the case, and you do the measurements and the measurements show you something different. And then you repeat it once or twice or three times, and then you disprove yourself. But that's how you learn over the time, So that's I would say that's positive, but I would say the only the most unexpected thing in my life is still the turbulence. So, so every time I'm in an airplane, just buckle myself and like whatever the pilot says, yeah, we're just going through some turbulence. Just based on all my experience for wind tunnel measurements, even if it's like a controlled environment, like you never know the outcome. So I don't want to scare the people on the call, but you asked me for the question was my unexpected experiments.
Definitely scare them. That's what we're here for.
Yeah, you got the answer.
Yeah, I'd prefer to not experiment with my air travel if possible.
Um,
Yeah.
have a question. What was or what does a typical day at work look like for you now? And what what was it when you started at Huber?
So when I joined Huber, that was about 15 years ago. Prior to that, I was working in the like consulting firm in the Boston SGH. So it was mostly commercial type of the work, focused on the modeling for residents outdoors. But when I moved to Huber, all at once you have to do some kind of lab experiments, backdoor experiments, which was slightly different framework compared to my previous experience. And I mean, it depends. If you're about to create some quite unique experiment, like it takes some time to go through thinking process and try to address all the possible like variables into that experiment. And then of course you realize once you start building the experiment, like, oh, I missed that part. So and you go back, you fix that and you rerun it, whatever, and improve it. But I mean, that's like iterative process. So I mean, nothing is really and written already what I'm doing. So you have to figure out the things which I kind of like. So like you can go and search in the literature, but most of the time you have to figure out things by yourself. Like how you're going to set up the experiment, what you're going to measure, what you're going to find out, and all these things. So that's a good question. Yeah. So
Because
that's how I started. It was like a lot of lab work, making all these assemblies
Mhm.
for testing, including test sets. Now I'm not that young stud anymore, so luckily we have a couple of younger folks on board that do, I would say, like kind of dirty work, but I would join them every once in a while, just like, yeah, I enjoyed like having hands on the thing. So definitely brings you some other type of experience instead of reading and watching, like.
so that sounds like you spend a lot of time at a desk, is what I'm hearing.
I mean, and traveling as well. So I've been involved in ASHRAE, a couple of technical committees, building materials, building envelopes, moisture control in buildings, similar with the ASTM. So it's a mix of traveling these things, being at the desk and being outside or whatever. Like, and sometimes you have to help whatever your technical people online with different questions or salespeople, and then comes, okay, maybe to travel, provide the support and talk with the customers and clients and all sorts of things. And so it's never boring. I would say it's always a mix of the of different things, which is good.
Because most of the testing that you're doing, this is generally, at least my understanding is these are assemblies, right? It's not generally just one material attribute that you're testing. So it's not like you have an ASTM standard that you can reference for like assemblies. A lot of this stuff, where I guess what I'm trying to get at, Danko, is where did the ideas of what you're going to test and look for uh, during these sessions, where does this come from? Is it responsive to failures you're seeing? Is it responsive to trying to look at material attributes under certain conditions?
So yeah, I would say both. I would say for I don't know how many people on the call are involved with the ASTM in general, and so ASTM standards like the acronym not a stupid test method. So it is really hard to connect the ASTM like testing protocols with with real life. And if you look historically, like, they're all like small scale, lab scale things to compare only just one particular aspect of the performance of materials, like very rarely with assemblies. So, and when you're looking for that type of the answer, like STM cannot give you that answer. So that's why you're going like the next step and trying to create all these assemblies, configurations, ventilation, different type of claddings, drainage properties, et cetera, and you want to test all these assemblies in different climates, all right? So that's how you go and building these test huts in different locations. And one of my dreams was to make mobile test huts on the trailer, so you can literally get in a truck and move them around like anywhere you want. So I still like offering Huber when I retire to drive one of these around the country, like and drink beer, like spend 2 or 3 months in California or Maine, whatever.
Sounds
Yeah.
like a good retirement plan.
Yeah.
Dango, would you mind bringing up your slides just
Sure.
so we can show people what some of these? I've had the privilege of seeing some of your test assemblies and uh, locations over the years, but I think it's really helpful for others to see it.
Sure. So I hope you guys can see this first slide of the short presentation.
Yes.
Okay, perfect. So, I mean, I'll start probably with the most interesting things. So if you look on this particular slide, this is one of the couple of the mobile test huts that we built over the time. So back in the day when I joined Huber, they had one stationary test hut in the Maysville, not far away from a commerce where the R&D is. And over the time, we said, well, we do not have the answers for different climates, and then let's think how we can maybe condense and like make like smaller scale and still be able to test like the real performance of the wall assembly. So what we currently have is one test site in Commerce and one up in Eastern Maine, where it's our like northern plant located, which is climate zone 6. So which is really interesting too. And we'll be testing like different things like zip-R panels compared to traditional continuous installation wall assemblies, a lot of focus on the stucco over the zip. And the latest round with test hut in the commerce, we just swapped all these walls. And the way I designed this test hut actually was like 2x8 wall skeleton with slightly over 4 foot rough open that you can like really exchange wall assemblies over the time. So once you finish one study, you can use the same facility to run another set and better experience, which is pretty cool. So right now we're doing like zip-R panels with, for instance, like with the rain screens, different propositions for ventilation stuck over it. So that's the most recent one. And just a couple of the photos just show the layout of the sensors in every wall assembly. You're trying to monitor what's going on in your wall over the time, including temperature, relative humidity, moisture content, strategic locations, etc. And on the far left, you see like that central post in the middle of the test hut. So that little big brain, what I call, has tied about 500 sensors to it. And for instance, like it took me 3 months to install the sensors on these things. So believe it, like whole summer, I just run the wire, label the wire, punch it down, connect, right, make sure everything works fine. And on
So
top of
I'm a sensor nerd, so I'm going to ask, those are what, Campbell's Scientific?
so the data acquisition system for this one is yeah, it is Campbell, which is one of the most reliable data acquisition systems. But all these sensors are, I got them from RDH.
Hmm.
So they make them and they're all hardwired, which is, I would say, a 21st century pain in the butt. I wish we had more readily available wireless technologies to be used in the building science. I mean, we have omnisense sensors, there's a couple other companies, but still, I would say that's far away from what I wish for to have it available and be used on a daily basis. So this is just example of what I call like a biggest BS fun. So these mobile test sets, I probably call them like the biggest rocks on my daily desk.
So are you like in Easton, you're watching winter conditions, I'm assuming, and in Commerce, you're focused on more summer conditions, or?
I mean, you monitor like all year long, so you can compare like what does it do in summer versus winter, regardless. So I mean, primarily your focus, what you're saying in cold climates, how it's going to perform in the winter time, and hot, humid, what does it do in the summer. But you keep collecting the data all year long.
So how long do you run these test cycles for?
So for instance, like when I run this test hot, like the first year when I go through the winter cycle, I just maintain, for instance, like relative humidity around 30%, like on cold climates. I don't want to go too crazy. Then I collect the data for that first year, and then I ramp up the relative humidity the second year, maybe 45%, which is a little high, and see how much trouble I'm creating in the walls. And once I'm done with that study, like the third winter, so I kind of make it like more humid to see how wet they get and how fast they dry out after that. And the third year is, maybe you cannot see in one of these slides. Maybe, yeah, you see on the bottom one in the comments, you see that little blue tissue. So every wall has like little, what I call wetting towel, like device or mechanism. I can inject the water either on the outside of the wall or inside of the wall and see how much that affects the moisture content in the sheeting. So the one on the outside, I would say, okay, there's some deficiency behind the cladding to inject the water. One behind the sheeting is one, okay, we have the condensation water leak inside the wall cavity and see how fast this thing dry out. So that's my third year experiment, and I try to create like maybe two, uh, I would say artificial leak events, two in the wintertime, two in the summertime. So to compare just the speed and how fast the things react to these accidental events.
Do you do you have like a worst case condition side that you park this on, like south or west or east, or like for anybody that doesn't know, backwards. He's like right here before the purple part, uh,
Yeah,
in the state of Maine. That's where they are, kind of
About
up here. So
firmly as climate 6 as one can possibly
yeah,
yeah,
be.
almost
yeah.
7. It's in Canada. We'll still claim it. But yeah, do you or like do you move it to a diff so Easton, Maine is pretty rural, right? Like we there's not a lot of people in that part of the state. So like do you park it next to a building or like have you done like
So
any
yeah, that's a little tricky because like these things need a power. So that's why we decided to have them on the Huber property because there's
Mhm.
no question. You don't need to worry about getting any permission from any utility company and have connected all. But I would back up a little bit to answer your question. Like when you set up these test cases, you typically orient your walls north and south. So I don't. Probably most of you know like which one is typically a reverse wall elevation, and north is I would call number one on that list. So you really want to get information how these walls perform like facing north. And it was interesting when I was doing some like initial rain screen, like testing behind the stucco, like and having like 316 versus 3/8, I would say like it would be the same spec for the south facing wall and north facing wall. And I even did some hygrothermal analysis afterwards to prove the point. For instance, if you had a Hearthstone veneer or the North Fall, that one might require a little bigger gap and better ventilation than the one on the south, which is interesting finding. So it's not quite uniform on all four sides of the world. So you have to think about that in your design.
Yeah, that was why I was wondering. I was like, wow, do you turn it 90 degrees sometimes and
Yeah.
try it again?
Well, you need some muscles to rotate this thing.
Some horsepower. Yeah.
Yeah.
I've
And it's
I
always
funny.
mean,
I
it
mean,
doesn't have a big lift and slide in it.
I can't remember, like it's probably like close to 18 or 20,000 pounds because when I was engineering this thing, I really wanted to make sure when you get on the road, the big exposed to 70 miles per hour wind, it doesn't blow off or do any damage to the desk. So there's a lot of hurricane ties, strap tie. It is definitely over-engineered. I mean, you won't believe
typical
it.
engineer.
I mean, one thing I keep saying, like in a worst case scenario, any hurricane like level 6 that would come through the area, I would just run up the hill and lock myself into this thing. I'm no joke. It may tumble over, but it's going to stay in a pretty uniform shape, like nothing would happen to it.
We got a question, Danko. So they're wondering what is the heating and humidification? So how do you kind of control the climates in these things?
That's cool question. So you can see on that first photo on the left. So what we use here, for instance, the one in the main was really well insulated assembly. And if you look at the square footage of this thing, it's not huge. So you kind of hit the wall there. They have to pick up the smallest of the smallest possible unit to heat up the space. So we had, I think it was like half ton, like a mini split unit mounted on a wall on the far front wall of interior. And of course, that one does the AC in the summer, but at the same time, I had to put like whatever circulating fan on the other side of the Tesla because it's like elongated shape. Just make sure I have good mixing throughout the whole area. And maybe you won't see on these photos, or maybe still you can see. You see that little metallic like silver tube mounted to that post on the back. So I was monitoring the interior conditions like on two different corners. There's a third post that you don't see on this photo, which is like facing towards us, and it has the same temperature and RH sensor inside of that tube. It actually created like double shielded like radiant cavity to eliminate any kind of radiation of the wall, just to measure what is the ambient air temperature without any radiation effect. And and I had like a dedicated whatever humidifier and a dehumidifier. So I would set them up like humidifier to maintain at least 30%, dehumidifier to maintain like 35%. So I could control the relative humidity really in a narrow range throughout the whole winter. Or like if you go to summer, you can really do like narrow tweaking and where you want to have your dial set up for this test. So
Yeah.
and it worked fine at the end of the day. But still, like when I was comparing these two locations, you would see like slight difference. For instance, like in a winter time, I forgot like one was showing a little higher in winter time and lower in the summertime. So like every time I bring new kids on the block in the Huber of the Hill to show the test hut, like I poke them with these building science questions to see how they think about the things.
Yeah, this is a good audience question. Do you always install the Huber products per, per perfectly or yeah or do you ever like overdrive the nails and not roll the tapes and all the things that sometimes happen in the field from what I've heard.
Yeah, yeah, good question. I mean, considering these walls are only 4 by 8, that's why we usually do the typical perfect install on that 4 by 8 like surface area. But that's why I introduced these wetting towels just to simulate whatever I had any kind of deficiency that creates a leak. And it's hard, for instance, like that's a legit question. It's hard if, for instance, if you overdrive the nails, how deep you go, will that one create a leak? So it's really not very controllable variable for the experiment.
Do you test for those kinds of things like in a more controlled environment in a lab or something?
Yeah, for instance, if you're talking about whatever we're doing nails, we did an extensive set of tests back in my early days because that was number one question when I started in Huber. And we were building 4 by 8 sheets and running that ASTME 331 water spray test with the wind-driven rain for about 50 miles per hour wind. And literally we would double the stud like on 4 by 8 and having like one stud perfect flush and then the next stud just driving the nails to different depths and even testing one with the shiners into the framing and testing different pressures for how long, see if they're going to create a leak. So
Mm.
yeah, good question. But yeah, but on these wall assemblies, it's really hard. It takes a little time to build these, like we talk, I told like I was just wiring this thing for 3 months.
Right.
So
Wow.
it's not easy. Like, yeah, I want to have a wrinkle on the tape. I can come like 3 months afterwards and change the wall. And so
And if
Since there's
we try and plan for every error that could ever happen, we're going to chase our tails into oblivion because we're never
yeah.
going to be able to solve for all the potential problems.
Yeah. I mean, and it's interesting to a good point, Ben. I mean, I had the circumstances that I was almost like stamping my initials and degree behind. I was helping to whatever build some demos with a perfect install, whatever, doing some crazy tests. And I would say, no way that's gonna leak. And well, that leaks, and 99% of the time when you don't care too much, it works fine. So like that's one thing I learned in my life. Like when I was really striving for something, 110%, that never became a true.
One
So
of the
just
things.
back up these days a little bit.
Sounds like you're getting a little older and a little wiser, is what that sounds like. Uh,
Yeah,
One of the
yeah,
things I just want to caution because we see it out there in media is that you can make tests lie, right? There's marketing that I see from all sorts of manufacturers where they're showing a supposed test, and it's not real conditions, right? Like you see tests that are
yeah,
like a Category 6 hurricane sustained for like 5 days is the equivalent of the hydrostatic force. It's like all I'm saying this is for people out there is you see tests, validate those things and question those things because it's very easy for us to be lied to through different media channels now
yeah.
and what looks
Um,
like an official thing, right?
yeah. Well, keep in mind all these videos are made for one particular purpose, all right? And then we are open, like I would say, probably the biggest can of the worms that bothers me mostly over day and night, like just execution of the things in the field, how well the things are done,
Mm.
and how much you can control that and keep an eye. I mean, I would say everyone on the call here is trying their best to implement these things, but you cannot be watching somebody 24/7 what they're doing in the field. And that's big discussion we're having even through ASTM and even codes. Do we need to enforce somehow QA QC of the installation in the field? But there's a lot of pushback on these things. But I think we need to do something more about it overall.
Or more training or professional licensing or
I mean, people are already doing the training and but in general, that's only, I would say, a fraction of the workforce that does that at the moment. But how you can make these 90% of the workforce to do their things better, on a daily basis.
Do you do any sort of wing nut testing where you test your products in the wrong application? Like somebody put a Vantech on the roof instead of, like do you do any of those wacky
like
things?
off-label testing, like
Yeah, like
using zip
like
tape for
what
windows
would
and
really
pickup trucks.
happen if this ended up in the wrong spot? Do you do any like wacky testing like that?
I mean, if you go to Florida, I mean, people are specifying even Advantic on the roofs just for like whatever the structural and hurricane resilience. So it can be done. I mean,
You
nothing
heard it
wrong
from
with
him.
it.
He says you can do it.
Yeah, check on it.
We use Advantech on our flat roofs, right?
Yeah,
Before our
Yeah,
right? Like
Yeah.
insulation.
it seems like
yeah,
a good experiment. Like your products could probably be used in applications that you didn't intend them for. And so like what's the failure point at like which somebody uses something
yeah,
somewhere other than, maybe not the thickness, but like the product that has a finish on it, or I don't know if you answered it because it was way early on, but someone said, why should or shouldn't they be worried about condensation on the backside of the zip sheathing, thinking about like SIP failures and how we install that and whatever. And so,
yeah,
people are thinking like it's not that, but it has this similar thing. And if they're using it in a similar case study, which isn't using it in the wrong instance, but it was a
yeah. I mean, it all goes back to the design. So, like, oh, you can go with Advantic on the roof, but then, like, again, you have to pay attention to this fundamental few building science principle, what's causing the problem in the roof assemblies. So, the Advantic wouldn't be anything worse. I mean, actually, might be even better, like handling that excessive moisture than other products. But at the end of the day, if you neglect all these things, like, nothing's going to survive 100 years.
All right, so we've seen the trailer. What else do you do, Danko? Let's see some other tests.
Sure. So I start with the biggest possible fun, and then I'm moving slightly, scaling down. So
You lied to me. This is the biggest possible fun. This one, well,
no, this one is like cushion in the lab, so it's not even outdoors. So it doesn't get bit up to the level it's supposed to be. I'm joking. So this is our new lab that we built just in the eve of the COVID time. And this store in the corner is what we call a weatherization chamber, and might look small in the picture, but we're talking about
It's big.
like 24-foot long, whatever, 20-foot plus long and 12-foot high. Uh, Chamber on each side with the two doors. You can literally set up independently two different environments on each side and perform, I would say, quite similar tests to the test huts with the outdoor experiment. The only deficiency is we do not have right now capability to run any solar and rain. So if I had those two features available and handy, I could probably run these tests indoors. But right now it's mostly temperature and relative humidity uh, focus studies. And what you see here, what we've done, that was kind of interesting story here before we launched the X Factor uh, for the flooring applications and proving that overlay on X Factor can substitute and act as a vapor retarder. So we ran the flooring study vertically, believe it or not. So uh, typically the dividing wall opening is about 16 like foot long, like 10, 12 foot tall. So you can run four full wall assemblies side by side. And then we said, since we're running the flooring assembly, like, yeah, let's utilize more space. So we cut the testing area for one wall in half. So we tested like 8 different flooring assemblies. Some of them have been by hardwood fall finish, some of them have been LVTs and LVPs, and we'll talk more about that. That's one of the topics I really wanted to talk about tonight. And it's on, on another slide down the road. So the big problem with these type of floor finishes is they're vapor impermeable. So if your flooring assembly is installed or like exposed to some moist, wet environment and a crawl space, that finish doesn't let any moisture to go through. So you're just calling like for slow dying of that assembly over the time. And we're getting more and more calls on that one lately.
Or
And
LVT over an existing concrete slab with questionable vapor barrier underneath it. That those are all over the place and
yeah, but I'm
low.
talking about over the wood. So
Yeah, yeah, yeah.
that's the worst possible mix of the things that you can have. And it's interesting the industry at the moment, especially the flooring industry, like they keep their eyes closed, and people like this. It's affordable, nice looking luxury vinyl, like so substitutes more expensive type of floor finishes with the same aesthetics and but there's there's a hidden
But
cost there. Yeah. I had to say but.
so true.
Yeah. So for instance, this was like small scale study and we were simulating like the crawl space from some study done in early 2000s. People were collecting the data for 100 plus whatever crawl spaces across North Carolina in 3 different counties. And I used their measurements to generate a profile for the wet crawl space for this study. And it was interesting overall. For instance, I had to fight these big fans in the ceiling. So because there are 3 fans in the middle of the chamber, like installed perpendicular to these assemblies. And I was thinking, well, in the crawl space, you don't see that much of the air movement. So we had to change all the tiles in the ceiling there where all these fans are to kind of like dilute the airflow, kill the airflow in the center. And I was going, for instance, on the bottom picture on the right, I was going literally with like wind speed meter and measuring the flow speed at every of these assembly, make sure I'm getting kind of the same airflow
Mhm.
speed. I mean, there's a level of detailing you
And
need to
is that
take
like
care of.
coming? Is that airflow from coming off of the cooling system? Is that
Correct,
yeah?
correct. And they have like these big fans that were designed to really mix the air well in these chambers. But for this particular study, you cannot afford that. So we had to like dampen the floor in the middle, still keep it on the corners. And it took some time playing around with like a chess on these like ceiling tiles. Let's put this one there, let the one there, measure the things and see how well it does. So just that part took like maybe a week.
Because I think it's worth clarifying here that one side of that chamber is heated and humidified, right? And the other side is cooled. So you're able
Correct.
to show you're carrying, it's not just a static condition that we're putting these materials in and measuring, you're measuring it with the temperature difference across that and humidity
Correct.
and vapor
You
pressure.
literally set up a full annual profile there. So I had literally temperature and relative humidity from January 1st to January 1st. And the good thing about the crawl spaces, they're not that crazy dynamic. They change on a daily basis. So you can literally go with some relatively like slow ramping up and down things over the time, but it will still be representative of your crawl space conditions. And on the other side, where you see all the sensors installed, this is all like whatever your house typically condition winter slash summer, relative humidity and temperature. And yeah, I would say the other big factor that really makes these failures to occur sooner than later is uh, people drop down their temperature down way too much in the summer. And this happens usually like in older homes, they do renovation, put this new flooring. They're not airtight, so they want to crank down the AC just to keep them cool, but they're not aware if you drop down from, I'd say, like design Ashford temperature for the summer condition 75. If you tell them 70, no, that's way too hot, they want to cool it 68, 65. And does that delta T like shortens the lifespan of your flooring from 5 to a year and a half or whatever? Things like that.
Mhm. And
Hmm.
really, all they're trying to control for is the humidity in this space, but they can't control the humidity because there's so
Yep.
much air
Yeah. Yeah.
leakage.
Yeah. Yeah. I mean, yeah, I would say if you can do anything else with your cold space, like throw some dehumidifiers. I know it's not cheap, but it still helps, over the time. Yeah.
Yeah.
So this was an interesting study, but my major message here is, yeah, be careful with these LVTs over the wood, especially the crawl space, and that's really problematic thing
So
to
you
do
did
with.
this for wet crawl space condition in North Carolina. Did you do the opposite for like cold climate people who fail to prepare their basements and end up with like moisture and stuff in the basements in the winter time or even in the summertime because the humidity is honestly, our humidity is probably not bad enough, and maybe it's not even an issue that comes across, but it's kind of curious for, I consider wet crawl spaces like you didn't condition that space, but I consider the same for
Yeah.
cold basements that are uninsulated and have weird humidity issues at different times
Yeah.
of the year.
Good question. We haven't, and I'll tell you, I probably have a laundry list like 3 pages long of different things I'd like to test, but it all depends on priority. Not for myself, but more for Hubert. So-
I'm impressed that you only have 3 pages. I think I had like 100-page booklet of like, ooh,
Yeah,
what if we looked at this?
yeah.
Yeah.
It's a Danko's legacy, like for future generations. Yeah.
Yeah. Well, this in response to that, there is a question that just back to the basics. What is it you're actually testing for? Is it moisture flow? Is it wood moisture content? Is it
Yeah, yeah.
yeah.
So we were really monitoring like the moisture content in the panels in different locations here. So we had the moisture sensors installed on the back side, on the bottom side of the subfloor. We also had some moisture sensors installed on top side of the subfloor below the hardwood floor finishes, and we had a couple of sensors installed on the hardwood floor to just see that moisture from crawl space, how much it propagates and affects every possible layer in your assembly, like how dangerous it is. So
Mhm.
yeah, we were looking for the moisture content in different locations in assembly.
Do you also do testing? So the flooring made me think of this as like different people install flooring different ways. So do you also do in your test heads, like some people will glue it down and like just material interactions with your materials?
Yeah, so I think some of these were actually like glue assist installs, so that they were like combo for glue, and you had to like think about, well, when I put my sensor, I want to like have it in the glue line, so we had to take a photo where the glue line is and make sure like whenever we put the sensors like in between, just a little monitoring the wood and then things like that. So just another little tiny detail on experiments when
Yeah.
you set them up, like all these crucial details, and nobody like who walks in like and take a look, wow, it's cool, and walks out, but he's not aware how many detailed pieces are behind that, you know.
For sure.
Good question. Yeah. I'm just looking 6:46. Should we scroll through the couple other
Yeah,
ones?
let's go to
Yeah.
another one.
I mean, we can
It,
talk all night long about this. Yeah. So speaking about these LVTs and LVPs, so last summer or fall, there's a builder who lives in the coastal area in Texas, Jason Harmon, and he's running like his little company is like high performance builder, and he builds a lot of steel homes, which is I would say more or less similar story to crawl space, especially in hot, humid climates. And he was trying to figure out what's the best thing, how to build these walls, sorry, like the floor assemblies. And he reached out to Huber. He's using the Huber products, and we started conversation, and we were sharing whatever the information was available at the time. And I'm just pulling out whatever the NHB study from 2014. What is the recommendation how to treat these floor assemblies the best you could and to avoid any moisture problems. Uh, so anyway, right now he has a project down there, and we started talking about maybe monitoring the flooring assemblies he's putting together. And actually had a FaceTime this morning with him. We provided some sensors for him, and basically what he's trying to do here is to literally have like the floor joist space like open web, and that's going to be like mechanically ventilated with some like through floor vents. Uh, and I said, okay, let's see like how this thing performed, and throw some moisture sensors and measure the moisture content like in the floor assemblies, a couple different locations, being close to these through floor vents in some dead zones, close to where he plans to put the mechanical supply that's space. So just like extension to that like weatherization chamber story. So we're not doing only like a lab, we're just doing with the customers and trying to figure out what is the best for the industry overall, like not only for Hubert. So, which I like these kind of projects and things. It's just true building science to me. And thanks God to Hubert that allows and supports this type of research. So not too many companies do that, to be honest, to this level. But yeah, I really like and appreciate that. Um,
We try.
the, the,
I look for stuff like that on our projects. You know, we're not doing it to the level that you are, but we'll have like weird concealed floor volumes, right, on some of our
mhm.
projects. Same thing. We'll
Yeah,
throw some sensors back there just to see. And a lot of times, 9 times out of 10, you're like, oh, there's nothing going on, which is great though, and it also helps you to understand better how to react to those
yeah.
assemblies and areas and buildings in the future.
But that one out of the 10 is the problem, you know.
Yeah, or the oh, I wasn't expecting
Yeah,
that.
yeah, yeah, yeah. Yeah, and in regards to this one, before we start into this really a field study, I did I don't know zillion of different Wolfie simulations, different propositions for the assembly, and you know like when you try to model, for instance, like Florida assembly and still homes facing the ground, like how do you set up your outdoor conditions? You know, that's a challenge in the Wolf. You know, you don't have like straight solar algorithm for the solar radiation just facing the ground. I think how you can like model
Reflected
whatever the
solar.
re-radiation from the ground of that stilt, and I mean all these little nuances for the modeling, how to model it properly the best you can.
What if you
uh
park a shiny pickup truck underneath the house for 3 months out of the year?
yeah, that's a good one. And you know the view factor, how that re-radiates on different locations in your floor about it. So yeah, so anyway, I was running different thicknesses of the insulation at the bottom, different conditions of fiberglass beds, some mechanical ventilation, good ventilation, bad ventilation, and I'm just like curious now what this study is going to show and compare that to whatever hygrothermal, how smart I was to do it without any real field tests. So that's always a challenge when you run hygrothermal analysis. I really that smart to capture what's going on in the real world. And I'll just tell the joke from my PhD days when I was doing all these experiments in a wind tunnel and doing a lot of CFD computational fluid dynamics with airflow. And there was a joke that goes like, you know, what is the difference between experimentalist and CFD guy or like any modeling guy? So the modeling guy is the only guy who believes in his results, and the experimentalist is the only one who doesn't believe in his results.
I think it's funny you flipped to this slide right as somebody in the comments had said, like the test sets are great. It gives us a lot of information, but these real world examples teach us something too. And so I think
Exactly.
it was
Exactly.
very pertinent that that was the next slide you went to.
Exactly. And my brain works really crazy. Like every time I walk around, like when I walk from the car to the office, I'm just looking the trees, the wind, the building envelope, and my brain works like that CFD model thing. Man, this is so many different processes happening simultaneously, like in that sophisticated level of the harmony. That's amazing. Like I get amazed every damn day. Like,
Well, can I ask a question about modeling? Because there's a lot of people that will hang their hat on modeling, right? Um,
Mhm.
how, I guess what I heard from your comment there is that it is very dependent on the person who's operating the model to put in good boundary conditions, right?
Exactly.
Do you
Exactly.
think that the majority of our industry that is leveraging these tools is doing it in a way that is actually giving results that are anywhere near real world?
Uh, I mean, it's a process when you start using these things. Like there's like that initial, I would say, excitement level that you think it's possible to do anything, like to simulate nuclear physics, like on the sun. But like the more you're dealing with it and you understand the complexity of all of the things going on, like you have to be aware the first of the model itself, the physics that's modeling. Okay, what you can model, what you cannot model, because there are certain things I don't know any software that's able of modeling everything that's occurring. So you have to be aware of that to start with. So then, okay, if I cannot model everything, let's see what's the most important thing I need to model when I model something, and go from there. And when you build the confidence, okay, that my software is capturing the most critical ones, then you focus on your like boundary conditions, which is a big thing.
Yeah.
For instance, if you go to Woofy, like air changes per hour of ventilation behind the cavity, behind the cladding in a cavity, yeah. Let's throw 5 air changes, but this thing changes like on hourly basis. They change it every minute, you know. And do you know the actual number of what's going on? Like, and it's hard to measure. I mean, some people try to measure. There's some limited information, but if you really want to capture that dynamics and that level of accuracy, it's hard. And then, like, who's really expert in modeling would say, okay, I cannot really model every little thing there, but if I can get decent trend or average of the things and use that, like, with certain level of confidence, that's why you're an expert at that point. So I'm just talking about genesis over the time, like how you like
Mhm.
mature and grow up, like using the modeling tools. So
Yeah, I know one of the conversations that I had with Stebrick about this is that we should be using these tools as a way to project the trends that we get from actual monitoring, right? So we run a test session for a period of time and see how something actually performs in the real world under a set of conditions and use that to tune the model to set our risk boundaries, right? And figure out like when
exactly.
is this
So
thing going to
yeah,
break? Don't just use the math to set the risk, use correlation from
exactly.
real measurements.
Exactly. So that's a critical piece of information that you need to implement in your models that's missing currently. And it's hard to build up and get that information. It takes the time and resources and money and everything. It's not cheap. I mean, like, yeah, it's relatively easy to wake up at 8 a.m. o'clock in your morning, like sit in your computer, drink a beer, and let's do some woofy.
I
I
think
mean, I'm
you
not
still have.
against that. It's still, I still use it. Like sometimes I get the questions about wall assemblies. On this particular occasion, using Hubert products or something else, how big the rain screen, what rain screen, and these type of things. So I still use like hygrothermal analysis to prove and see how safe we are with certain propositions. So it's still valuable too. I'm not against it. Like I would say Joe is probably a little more against it. Like he's
Yeah, yeah.
more like
And it's not, I'm
experienced
not,
guy.
I'm
Yeah.
not trying to dog on it. I just think it's valuable for all of us to understand what it can and can't do because you'll see people making wild claims about failures or successes based off of modeling. And
Yeah.
just any tradesperson that's been around buildings for long enough, sometimes you'll look at it and you'll be like, there's no way that's going to work. And that's based off of, anecdotal real world experience of buildings, right?
Yeah.
So,
Yep. Yep.
Yeah.
Exactly.
You still have two more slides, and I think they would love to
Okay.
see them.
Yeah, we have
We'll
4 minutes
even
to.
let you talk past 7 o'clock, depending
Okay,
on how
I'll
people are
go
feeling.
quickly through this one because the one I put at the very bottom is quite interesting. So this is like one of the our like backdoor like backyard tests when you do not have like resources and time to put that crazy detailed test out with 500 sensors. They want to build something quickly to prove disprove a certain point. Like for instance, these are all stucco walls, not fully conditioned space. We just made these boxes that are kind of semi-conditioned closed on each side by like had like 4 inch like undercut the door, so there's still some air exchange, and the sun hits the whole box, so you have that delta T almost like some ventilated like attic space. And we had some like stucco walls with rain screens, without rain screens, and just measuring the moisture content with and without the water injection in the stucco. So if you see that little figure on the left upper corner, like I drill like 15 holes through the stucco to gather water every time it rains through this trough into the wall, deposit it, and just measure what's going on. And you're just like, okay, yeah, the brain screen, yeah, does the job for the most time, like that's pretty cool. So, and people like we have a lot of people coming and touring our facilities lately, almost turning into like I would say 2 day a week full-time job to handle the people who come as visitors and touring, and they love this thing. Literally, they can walk inside and see some of the back surface of this OSB. Uh, I would say even rotted right now. They had the rain in it, so that's kind of interesting. But anyway, okay, three more minutes. So if and what you see here, like it wasn't fully finished wall assembly, so I was thinking, well, how can kind of like do a smart thing to simulate the actual wall assembly with insulation and drywall, and I said, okay, I'll just put thick plastic and undercut like 12 inches from the bottom. So I think I'll have some exchange of the heat and air and moisture just to like respond to data dynamics overall, and turns out to be like relatively decent setup. Like here, like four moisture content sensors, one in the mid bay capturing any water leak, the one on adjacent bay in the same height. Okay, how the rest of the wall that's not affected by the rain responds like in real life. So that was kind of cool study. Relatively dirty and cheap to build and execute, and but still provide some useful information overall.
There's probably no like perfect test case that will give you everything that you want to know and all the studies and all the things. Yeah,
No, I
so
mean, yeah, yeah. It's almost like going back to music. You cannot create your masterpiece, Okay, every time you write a song or a composition, like I can always do it better. The same with experiments. Like there's no perfect experiments. So once you finish one, okay, you learn, I would say at least dozens of the things that you didn't think of when you started experiment.
yeah.
And this is what I call a little dirty, small BS fun. I don't know if you guys ever heard about this rap product that claims it has R6, believe it or not. And the first time I was approached with this question was, I don't know, maybe 2016, 17. And it went away for 2 years and it came back to me again after 2 years, once a year. And um, last year I got probably a dozen times people asking me about this. So it is the company who makes this, whatever, the wrap and claims they tested this wrap and has like R6, believe it or not. And they, in their test report, which is, I don't know how to define, explain the test report. The reporting numbers is all over the place. The units are messed up. But anyway, the way they tested this material with air gap. Typically, the way you test per STM standard, you have like two big plates sandwiched like your material in between, and you just run some heat flux, measuring the heat flux top and bottom, certain delta T temperature, and measure what that heat flux is. And they claim they ran this test like with some air gap, which I don't know how that's possible at all. They ended up in a court, and there was a guy, David Yarber from R&D Services, PhD guy, and older than I am, but he's probably the best expert for insulation in US. He testified at the court. He turned them down. They made appeal, and after 3 times, they turned him down. So, and asked him about this. He said, "Please don't remind me of this at all." So anyway, I was thinking like how you can prove like to like common people like that this is a BS, right? So then I said, well, let's kind of replicate and that whatever that heat flow meter test, but put that heat generation by source in the middle and just sandwich that heat source with two layers of this material on each side and just do air seal edges. So I looking online and found these whatever like reptile heating pads. Cool. I bought two of these, $20 a piece. Then I built the same similar assembly like with the polyiso, but it's a little bigger than this Insultex demo because if I had that like heating pad to the edges of the polyiso, it would still have some excessive heat loss through the edges. I said, okay, I'll build a cushion of like 1 inch polyiso around that heating pad just to eliminate that side effect and thermal bridging on the sides. And I found on Amazon this little device that measures like how much energy you're using over the time. And the good thing is it has a temperature control. So I set up the both of these. I put it like like thermocouple in the middle to 100 degrees, and okay, let's see what's going to happen after a couple of weeks or days. And if you look at the energy consumption of the one with the polyiso, 1 inch polyiso, which is R6, it's about 2.7, 2.9 kilowatt hours, and the one with this magical wrap is 18, 19. So it's like 6 to 1, 7 to 1 difference. So just the things like small scale things like that, like on daily basis or just for fun, you know.
Nothing like a little
Yeah,
BS products. Someone wrote in the comments.
exactly. And I mean, you guys on the other side of the front in this battle, and I mean, I understand if you're trying to specify and look at some product, whatever performance data, and they provide you with the official test report that claims it's like, well, some people buy that story, you know, but then again, you always have to test your common sense. Like it doesn't look that real. I remember my first response about 10 years ago to this one was to that person. I would sponsor the trip to owners of this company who invented this product, like the northern part of Canada, and provide 2 rolls of this product. They can wrap it up around their body how many times they want. If they survive for 2 weeks in the cold with their wrap product around their body, I'll buy it. That's common sense building science experiment. So yeah, so this is my last slide. So just the things that my brain is occupied on daily slash monthly slash annual basis.
I want to be you when I grow up. I think I could really get into all of this fun experiment stuff. Thank you
Yeah,
so much for coming and sharing this stuff with us, talking about your test huts. I know we tried not to get into anything you're not allowed to talk about, but we really appreciate you coming and sharing
yeah,
with
yeah.
everybody
It
tonight.
was a great talk. I mean, yeah, I'll try my best like to participate more regularly on these calls. It's a little tricky because it's 6 p.m. and I work till 5. I do not live quite close to commerce, so it's about hour commute for me, at least fighting Atlanta traffic to get back home. So
Old Uncle Huber can let you out 15 minutes early once a month.
okay, please record this one.
I'll send an email for you.
We'll put in a
I'm sure it'll
request.
get read.
Official, like yeah, 4 p.m. on nice, cool.
Uh,
Yeah, it
thank you,
was a good
Danko.
one. Yeah,
Thank you,
Danko.
everybody, for joining us. This was awesome.
Yeah. Thank you,
have a good
everyone.
one,
Have a
guys.
great night.
You as well.